Hi guys, welcome back. Let's continue with electrostatics, grade 10 learners. So today we'll try to finish all topic and we are gonna answer some practice questions. Electrostatics. Okay, first of all, definition we should know, and then all coming from atom. In atom, we know we have three particles: neutron, proton, and electron. Electron is moving, transferring from one to another, and then making charge objects. Let's continue. Quantization of charge. So if you have one electron, your charge is QE, negative 1.6 times 10 to the power of negative 19. It is constant number charge for electron. If you have two electrons in one object, so 2 times QE, 2 times 1.6 times 10 to the power of minus 19 coulombs. If you have 3 times by 3, 4 times by 4. So number of electrons times by charge of electron, giving you charge of object. And then unit of charge is coulomb. Symbol is Q. Let's say you have object A, charge is 5 coulombs. Okay, symbol Q, unit C, coulomb. So we are learning this one. One electron charge QE. Okay, Q is equal to N times QE, and full definition is here. We should know quantization of charge. So unit of charge is coulomb, symbol of charge is Q. We have done. And then one electron charge negative 1.6 times 10 to the power of negative 19 coulombs. All right, now we have one example here. An object has 5 electrons. An object has an excess of 5 electrons. What is the charge on object? Okay, so number of electrons given 5, and we are looking for charge of electrons. How we are gonna calculate? So charge of object equals 5 times negative 1.6 times 10 to the power of minus 19. Why negative 1.6? Because it's excess electrons. So excess electrons, because of that, we are using negative, so more electrons. Q equals 5 times 1.6, getting what? 8 times 10 to the power of minus 19 coulombs. All right, so when you calculate 5 electrons object, charge of 5 electrons object, you are getting that number. And then, okay, let's continue. Charge object. We have neutral object. Neutral object means you have same number of proton and electron in object. So as you see, we have 3 protons and 3 electrons. This is neutral object. Charge is 0. Q is equal to 0 coulombs, we can say. And then positively charged object, we have more protons. Positively charged object, Q is equal to plus, how many? 1, 2, 3, 4, and the minus, so plus 2 electrons, 2 times QE we can write. So plus 2, 3, 2 times 10 to the power of minus 19 coulombs. Because we have our formula, Q is equal to N times QE, but it is positive. We are going to use QP. N is equal to, so Q is equal to N times QP. All right, positively charged object. And the negatively charged object, we have more electrons. So these electrons, they cancel each other, proton cancel. How many times we have more? 2. Or you can use this way, negative 4 and plus 2, getting negative 2. So 2 electrons, 2 excess electrons we have. Charge of this object, charge equals N times QE, and N is equal to 2 times, now negative 1.6 times 10 to the power of negative 19. Why? Because we have excess electrons. This one, it was less electrons, positively charged, but now you have negatively charged. Charge of object equals, now we are going to use positive, negative, yeah, negative 3.2 times 10 to the power of negative 19 units coulombs. C. All right, I hope everything is clear. So we have three different objects, three different charge object, neutral, positively charged, negatively charged. Neutral charge, same number of protons and electrons. Positively charged, more protons. Negatively charged, more electrons. Okay, we have charging methods, charging by friction. So if you have a plastic rod and then cloth, initially both of them neutral. Plastic and cloth, both of them neutral. Neutral means zero charge, 0 coulombs each. So when you rub them, electrons moving from cloth to plastic rod, electrons moving. Do what we said, only electrons can move. So when you rub them each other, so electrons moving from cloth to plastic rod. So as you see, plastic getting negatively charged and cloth getting positively charged. We should keep in our mind any object, any neutral object collecting electrons, gaining electrons just like plastic rod, getting negatively charged. Any neutral object losing electrons, getting positively charged. Glass and cloth now, initially both of them neutral, so 0 charge, 0 coulombs, and then cloth also 0 coulombs. Now electrons moving from glass to cloth. All right, electron transferring, opposite direction now. So glass losing electrons, getting positively charged, cloth collecting electrons, gaining electrons, getting negatively charged. Charging by friction like this. So next one, let's see what else we have. Polarization. Polarization process between any charged object and neutral object. In neutral object, as you know, we have protons and electrons. So just like this, electrons, protons, same number of protons and electrons we have, but positions, as you said, put one more, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Same number of protons and electrons, neutral object. If you take and put charge object, now positive 1, if you just coming closer, it is coming closer, attracting all electrons. Attracting all electrons this way, and then this side positively charged. This process name is polarization. If they ask you why charge object, positive or negative charge object, attracting any neutral object, you can say because of polarization. Okay, this is process name, polarization. Let's continue with next one. Charging by conduction. So we start with charging by friction, plastic rod and glass, please remember that. And then charging by polarization, we can say polarization process. Now charging by conduction. Charging by conduction, first of all, if you have two charge objects A, let's say, object A with Q1 charge and object B with Q2 charge. And then they touch each other and separate like this. They're coming closer and touch each other. So A, B, and then you separate them. When you separate, after separation, after touching each other, new charge, both of them getting final charge, Q final, they're having same charge. And then they repel each other. Initially, they attract or repel, depends on what charge they have. But now, after touching each other, they're going to repel because they're having same charge. Well, how we are getting this charge? First of all, you are adding charges, Q1 plus Q2, divide by 2. You are just adding charges and divide by 2. Examples coming now. So let's continue. Charging by conduction, just like this. You add charges, divide by 2. Conservation of charge now. So what we know, the total electric charge, total amount of electric charge in an isolated system remains constant. This is conservation of definition. We should know this. And using charging by conduction. So if you have two charge objects, X and Y, we have different charges. When they touch each other, getting same charge, end of the final charge. How we are getting final charge? Q1 plus Q2 over 2. Before we start answering our questions, let's give units. Units, converting it. Okay, before just question, I think after this questions coming. Yeah, before questions, let's give these units, converting units also, let's explain. If you have 5 tera-coulombs, so how we are going to write with coulombs 5 times 10 to the power of 12 coulombs. Okay, we should remember these numbers. Oh, tera to pico. So this is tera 10 to the power of 12. If I have 2 GC is equal to 2 times 10 to the power of 9 gigabyte. Do gigabyte also, you know, megabytes, you know that, right? So this is not just electrostatics. This converting units for all about units, all you other topics also we are using. Mega 10 to the power of 6, kilo 10 to the power of 3, deci 10 to the power of -1, centimilli, but these are milli micro using 10 to the power of -6, nano mostly coming with nano 10 to the power of -9, and pico 10 to the power of 12. Let's say 4 nanocoulombs. How can we convert? 4 times 10 to the power of -9 coulombs. This one, we can use other units, unit of length and the unit of current, and then unit of force. You know, you can use for other, for example, meters. Let's say 5 millimeters. So 5 times 10 to the power of -3 meters. If you have 12 microcoulombs, one more time coulombs, because our topic is electrostatics. So 12 times 10 to the power of -6 coulombs. Please try to memorize these all units because we don't know which one coming in your question. All right, we have done. Now we can go to our questions. Before we go to questions, one more time, quickly, let's see what we have in this topic. After that, we are going to examples. So let's just go back. First one, electrostatics. Electrostatic, everything starts with atom, electrons transferring and making charge object. One electron, -1.6 times 10 to the power of -19. And then to calculate total charge, number of electrons times charge of electron. And what else? We have quantization of charge by this formula. We have 3 different charge objects: neutral, positively charged, and negatively charged. Positively charged, more protons. Neutral, they are equal. Number of protons and number of electrons equal. Negatively charged, we have more electrons. And charging by friction, plastic rod collecting all electrons. Glass rod, it doesn't like electrons and giving electrons. Direction of electron transfer from cloth to plastic, glass to cloth. All right, this one. And then polarization, charging with, just without touching, let's say, charge object and neutral object just coming closer and attracting electrons inside. Charging by conduction, they touch and separate to get new charge. We are adding and divide by 2. And then observation of charge, this definition we should know. What else we have? These units and done. All right, from now, questions. Okay, question 1. What type of force do they exert on each other? Guys, from now, let's continue with questions. If we miss something, because just we had our revision, we try to cover all topics, but if something is missing, with questions, we are going to cover and finish all stuff. So what type of force between these two? We have attractive electrostatic force. Let's write attractive electrostatic force. Electrostatic force. Next time I will try to write much better. Why attractive? Because we have negative and positive. We know unlike charges attract each other. Okay, this rule we can use. Unlike charges attract each other. All right. So, unlike charges attract each other, because of that, we have attractive electrostatic force. Okay, question 1, simple one, but I forget to tell you, just revise So maybe other practice questions you can do it. If you want, I think it's much better for you. You can try first and then you can check answer. I will just wait a few seconds to stop video and then you can just pause the video and then you can try first and then you can come back. I think it's much better for you. Okay, let's use that way. Question 1 done already with you, but question 2 you can try. Question 2. How many excess electrons are there on the object X? Okay, now they're asking you how many electrons, how many excess electrons on the object X, because this is negative. Excess electrons, they are saying. Please stop video and try first. We are going to use our formula, quantization of charge formula. Okay. I hope you have done. Yes. Okay, we can start. How many electrons in, oops. Okay, let's answer this question together now. I hope you have done already. So formula is Q equals N times QE. What was the Q? Charge of object. It is given here. N is number of electrons. Q is charge of 1 electron. So from this formula, we can write N equals charge over QE. And charge is negative 7 times 10 to the power of minus 6 over negative 1.6 times 10 to the power of negative 19. In formula box, you will have these all. So this constant number and formula, everything. So you just calculate this one. N is equal to, let's use our calculator, 7 over 1.6. And then we are getting this number 4,38 times 10 to the power of negative 19 is going up 30. Okay. Electrons. We are not writing coulombs here because we are looking for number of electrons. So you calculate excess electrons are there on the object X. So how many electrons more? Normally, you know how many electrons more, how many electrons in the object X we can say. So next one, next question is coming now. Okay, let's clean up. So question 3 is coming now. Please try first. All right. Because of time, just maybe some learners will try, some learners will not try. Because of that, I want to continue. But if you try, it's going to be much better for you. Please stop video and try first. Okay, I hope you have done. Yes. How many electrons have been removed from the object Y? Okay, initially neutral. If you add electrons getting negatively charged, just like X, if you remove electrons from object getting positively charged, just like object Y, as you see, questions different. So first question, so it's question 2. How many excess electrons are there on the object X? Because it is negative, excess electrons. But now they said how many electrons have been removed from the object Y? Because when you remove electrons from neutral object, getting positively charged. All right. So same calculation, but now positive. I think you have tried, we did try already. Let's answer together now. So now what we are going to do, formula still same, Q is equal to N times QE. N equals charge over QE. And then our charge is plus 3 times 10 to the power of negative 6. I said plus because you must write plus 1.6 times 10 to the power of minus 19. As you see, on top we have positive, and this one also positive. Remember, we have charge. It means we are using charge of proton because same charge. So formula N equals Q over E. If on top you have positive, other one is positive. So N equals, now we are calculating 3 over 1.6 now. 3 over 1.6 is equal to 1.88 times 10 to the power of 13 electrons. Done. Number of electrons. How many electrons removed from object Y, from neutral object Y, and then you are getting positively charged object. Okay, question 3 done. Question 4 is coming. The simple one. Even you don't need to stop video, but just try. Now, they contact each other and separate from each other. Okay, initially we said we have attractive electrostatic force. Now they said they touch and separate. What type of force do they exert on each other? Please stop video and write your answer in 2 seconds, in 1 minute. You can write it down and then you can come back. All right. So when they touch each other, what type of force we have? When they touch each other, guys, what we know, they are having same charge. Next question we are going to calculate. And then for now, just let's write, we have repulsive electrostatic force. All right, electrostatic force. Repulsive, why? Because when they touch, they are having same force, same charge, sorry, they are having same charge. We are going to calculate it by using Q1 plus Q2 over 2. All right, repulsive electrostatic force. Question 4, answer is repulsive electrostatic force. Next one, what is the direction of electron transfer? All right, always from more positive, let's write from more negative to less negative. Okay, this is our reason why the electrons move from one side to another one, and then giving us reason. So answer is X to Y. Okay, from more negative to less negative. Always you can give this reason for your answers. Even you have plus 7 minus some plus also fine, positive, because let's say for example, plus 2 plus 7. If you have coulombs like this, so electrons moving this side, Y from more negative to less negative. Reason always same. But to get correct answer for this kind of questions, you can use number line. Or just, you don't need to draw always. So -1, -2, -2, -3, 1, 2, 3. This way. All right, electrons moving from less number, small number to big number. Now you have -7 and +3. So -7 is less than, but you must check 10 to the power of something, what you have. -7 is less than +3, so answer is X to Y. All right, just check number, which one is smaller, from small number to big number, electrons moving. If they ask you reason, you are going to say from more negative to less negative charge object. All right, so let's continue with next question. Direction of electron transfer is fine, I think. Now they're asking you calculate the new charge on each object. Guys, they can ask you calculate the new charge on object X, calculate new charge on object Y, or calculate the new charge on each object. Same calculations. What we are going to do? What we are going to do now? But oh, sorry, you just wait a few seconds. You can stop video and you can try. Waiting. Yes, you have done. So let's continue with you. Q final equals Q1 plus Q2 over 2. Using this solution, Q1 is -7 times 10 to the power of -6 plus 3 times 10 to the power of -6 over 2. And getting -4 over 2 is -2 times 10 to the power of -6. Our unit is coulomb. Don't forget to write unit. If you forget to write unit, unfortunately, you are losing your mark. 1 mark is going, you can say bye-bye to 1 mark. So Q final is equal to Q1 plus Q2 over 2. when they ask you, they touch each other and separate from each other. And what is new charge? You must use this formula. All right, let's continue with next one. How many electrons are transferred? All right, they touch each other. They are getting new charge, but asking you how many electron transfer. We know electrons transfer from X to Y. Okay, but now they're asking you how many electrons transfer when they touch each other. How many electron transfer, number of electrons, we are gonna calculate. Please stop video and try first. Yes, waiting for you. A few seconds to stop video. Yes, we said you done, you have answer. Let's start. Our formula, Q equals N times QE, and N equals Q over QE. But now we are using delta Q. What is delta? Change in charge. So N equals, we can write N first. N equals, we are using N is equal to delta Q. N equals Q final minus Q initial over QE. All right. So delta means change in charge, because we calculate already Q final. If we didn't calculate in the other question, we should calculate Q final first, and then we should calculate number of electron transfer. We calculate, and then we said minus 2 times 10 to the power of minus 6 minus 2 times 10 to the power of minus 6 coulombs. New charges, both of them have same charge. Now we are trying to get how many electrons transfer from X to Y. We are using Q final first. Q final is negative 2 times 10 to the power of negative 6 minus, for Q initial, you can use this one here or X or Y, which one you want, you can use it. All right, let's use this one, Y. So negative, so minus Q initial is equal to 3 times 10 to the power of minus 6 over QE. What is QE? Minus 1.6 times 10 to the power of negative 19. So we are calculating with Y, and then we are going to calculate with X, and then we should get same answer just for option 1, option 2. But which one you want, you can use it. So N equals negative 5 times 10 to the power of negative 6 over negative 1.6 times 10 to the power of minus 19. Please remember, if you put on top X or Y, and if you get positive on top, this one, QE, change to positive. If you have negative, you must use negative. All right, remember that. And then we can calculate it 5 over 1.6. And then we are getting 3,13 times 10 to the power of 13, right? Yeah, 13 unit electrons. Number of electron transfer, we are calculating like this. So number 1, writing formula. Number 2, number of electrons formula. We just get it, Q final minus Q initial. We said we can use with X or Y. For now, we are using with Y, negative 3. Let's calculate same thing with X. So let's write our formula first. Q is equal to N times QE, and then N is equal to delta Q over QE. N equals Q final minus Q initial over QE. Till this step all same. From now, something's getting different. Negative 2 times 10 to the power of minus, what was it, 6, minus 7, negative 7 times 10 to the power of minus 6. All right, so divide by 1.6 times 10 to the power of negative 19. It's positive and negative, we'll check now. Negative, making positive. So negative 2, positive 7, making positive 5 times 10 to the power of negative 6 over 1.6 times 10 to the power of minus negative 19. As you see, on top we have positive, and then this QE change by positive from negative to positive. Our answer is 3,125 times 10 to the power of 13 electrons. Number of electron transfer done. Step by step, we are trying to answer all types of questions with you. We have done question 7. Let's continue with next question. So what we have now, question 8. For question 8, same process. Please try first. All right. Now, charge is given, asking you number of excess electrons. Okay, please try. Stop video and try, please. All right. Yes, I hope you have done. So let's continue and let's get number of electrons. What was our formula? Q equals number of electrons times QE. This is my Q, sorry about that. QE. So number of electrons we can use N equals charge over QE. And charge is negative 3.2 times 10 to the power of minus negative 19 over negative 1.6 times 10 to the power of minus 19. When you calculate this, you can get N equals 2 electrons. Done. This is not number of electrons transfer, guys. This is charge on one object. You have object here, let's say object X. On object X, you have charge negative 3.2 times 10 to the power of negative 19 coulombs. Charge is given, asking you how many electrons. Do you remember we said if you have one electron in one object, charge is equal to QE is equal to negative 1.6 times 10 to the power of negative 19. Excess electrons means how many electrons more than protons, because if you have same numbers making 0. Okay, this one excess electron. So charge is given, number of electrons, calculating like this. If you don't want to write formula N equals Q over QE, you can just carry on with our formula from formula box like this. So you can write negative 3.2 times 10 to the power of minus 19 equals N times negative 1.6 times 1.6 times 10 to the power of negative 19 and divide by negative 1.6 times 10 to the power of 19 each side, negative 1.6 times 10 to the power of negative 19, and this one cancel each other, and then what's left? N equals 2 electrons. Other option. All right, for you, other option is here. Okay, let's continue with next question. Calculating number of electrons in any object using this way. So now long question, question 9. Okay, a glass rod gains a charge of, don't misunderstand, gains not electron, gains a charge. Gains a charge plus 23 picocoulombs. You remember that pico, right? So when it is wrapped with a silk cloth, how many electrons are transferred? Which material lose electrons? What is the charge on the material which gains electrons? Okay, so it is long question. Maybe you can take your 5-10 minutes. You can try, you can answer everything. And then when you come back, we are answering all of them. All right, question 9. Just wait a few seconds. You can stop video. And always I'm reminding that because it is very important. Trying is very important. I was saying to my learners, try or die. If you try, you are gonna get it. You are gonna get good results. You are gonna try. If you don't try, you cannot get it. Please remember, let's try. All right, you have done. Now we are gonna answer together. Long question, question 9. So now you have charge object glass rod positive 23 pico. So let's write our charge first. On top we can write here charge equals, and we can change our color also. Charge equals positive 23 times 10 to the power of minus 12 coulombs. Okay, this is our charge. 23 times 10 to the power of negative 12 coulombs. Okay, How many electrons are transferred? Yes, we have one charge, and what's going on? So we are going to get lost now. But glass rod gains electrons charge when it is wrapped with a silk cloth. So initially, negatively charged. Maybe we can say in the question we should mention that. Initially, they have negative charge. Do you remember glass losing electrons and getting positively charged? So our formula equals Q equals N times QE. And then you can write N equals delta Q over QE. Just to understand, writing all steps. So N equals Q final minus Q initial over QE. And Q final is 23, positive 23 times 10 to the power of negative 12. Oops, minus 0, because initial charge is 0. And then 1.6 times 10 to the power of minus 19, negative 19. And then we can calculate 23 over 1.6. 23 over 1.6 equals 14.38. Okay, 14.38 times 10 to the power of negative 12, positive, negative, going up, so 7. Unit electrons. How many electrons transfer? We are calculating like this. All right, I hope you are okay. So Q final minus Q initial over QE. Which one lose electrons? Which one lose electrons? Of course, plus. Why? Because getting positively charged. What we said, any neutral object losing electrons, getting positively charged. As you see, it has positively charged, so it means glass losing electrons. And then what is the charge on the material which gains electrons? Which one gains electrons? Let's check. Silk, cloth gains electrons. Okay, cloth. They don't ask you which one, but this one is getting electrons. But now asking you charge on that. Charge is negative 23 picocoulombs. It means negative 23 times 10 to the power of negative 12. Why? Because you have glass. Let's explain now one more time. Glass and cloth. Electrons moving from glass to cloth. Initially, they are 0. If this one is getting 23 picocoulombs, this one negative 23 picocoulombs. Because initially 0 charge, we said, right? 0 coulombs, 0 coulombs. What's our total charge? 0 plus 0, 0. Now also must be 0. 23 minus 23, getting 0. Because total charge never change in a closed system. Do you remember conservation of charge? All right, question 9. Long question done. I hope everything is fine. Calculating how many electron transfer using this one. Which one losing electron getting positively charged? Which one gaining electrons getting negatively charged? Question 9 done. I think we should slow down. Okay, question 10. Question 10, we have question 10.1, 10.2, but 10.1, for 10.1, please stop video and then try first. They touch and separate. You have two charged objects plus 2 nanocoulombs, NC, and negative 6 NC. They touch and separate. What is new charge on each sphere? All right, so this is your question. Please try. Question 10. All right. I think you have done. I hope you have done. All right, let's answer this question now. New charge we are looking for. Q final equals Q1 plus Q2 over 2. Okay, new charge we are using like this because we have two objects, object A, B, let's say, object A and B. First one, Q1 with plus 4 nanocoulombs. Second one, minus 6 nanocoulombs. So we can carry on with nanocoulombs, it's fine. Plus 4 plus minus 6 and divide by 2, getting minus 1 nanocoulombs, nano negative 9, negative 1, nano 10 to the power of negative 9. So let's just write again. So negative 1 times 10 to the power of negative 9 coulombs. Done. All right. This is our new charge when they touch each other. That's it. Okay, let's continue with next one. 10.2 is coming now. Question on top. Small identical spheres as they touch each other and separate from each other. Now they are asking you, name and state the law that you applied on in 10.1 to calculate the charge on sphere. So you are going to say, because of this. So you are going to write name and definition. 3 marks question. Okay, waiting for you now to stop and try. All right, so this answer, conservation of charge. The total electric charge in an isolated system remains constant. We are using that because total charge never change, we said, right? We are using Q1 plus Q2. What we know, they are just sharing total charge. All right, question 10.2 done. From now, we are going to some multiple choice questions. So some easy questions for you. Okay, now question 11. An object which is charged positively. Yes, which option is correct? Lost protons, lost electrons, gained protons, gained electrons. What do you think? Please try first. Question 11. Multiple choice question from past papers. All these questions from past papers, from final exam or final exam, I don't know, but from past papers. Okay. Please try. Okay, wait for you a few seconds just to stop video. All right. So now question 11. An object charged positively. Positively means losing electrons. All right. So what we said, any neutral object losing electrons, getting positively charged because electrons negative. They are just giving negativity everywhere. So electrons negative, electrons moving from one object, so getting positive. That object getting happy and then getting positive. So lost electrons, our answer. Let's check all options, but let's give correct option first. Answer is B, lost electrons. Lost protons, never. Protons, they are lazy. Remember, guys, protons never move. Gain protons, wrong. Gain electrons, getting negative charge. It's a possible option, but they said positively. Because of that, not our answer, but gain electrons, getting negative. Next time, maybe they can ask you negatively one. So that time you can say gain electrons. Which one? Losing electrons, getting positively charged. Our answer is lost electrons. Question 11, done. Question 12, asking you charge. So what we know, like charges repel each other, unlike charges attract each other. You know that. So please try to get charge for A, C, and D, because charge B is given. All right, I will wait for you a few seconds to stop video. All right, so we can start and answer what they said. In this question, they said charge of B is negative. If charge of B is negative, charge of A is positive, certainly positive. What about C and D? Another system. So if C is negative, D is negative. If C is positive, D is positive. So what option is right? What options we have? Let's write here. A, C, and D. A, positive. Certainly we know that. B, so B negative already given. So C, positive, positive. Other option, A is still positive, always positive, because they attract each other. And then C, if C negative, and D is negative. So maybe all of them positive, maybe positive, negative, negative. Let's see what option is given. Option A, charge of A is negative. No, that's gone. This one is gone. Charge of A is positive. Yes. Charge of C is positive. Yes. Charge of D is positive. Yes. This option is helping us. That is correct. This one here, positive, positive, positive. Others, A is negative. No, it's gone. And then A is positive. Yes, possible. C is positive. Okay, but D is negative. No, if C positive, D negative, they're going to attract each other. But what we know, they repel each other. All right. So just like this, We are answering question 12. Answer is B. I hope your answer also right. So next question, question 13. A neutral plastic rod wrapped with a dry cloth, okay, and then charging with negative 3,2 times 10 to the power of negative 9 coulombs. This charge obtained by, yes, please try first. Just a few seconds to try, and then we can carry on with you. Now, charge is given, asking you how many electrons transfer. Neutral plastic rod, initial charge is 0. Remember that. All right, okay. We can start and answer this question now. So, what's going on? Let's try to understand question first. You have neutral plastic rod, okay. Neutral plastic rod, Q initial Q1 or Q initial, we can say Q initial is equal to 0. And then you have cloth and Q initial for this one also 0. When you wrap them each other, so you are getting Q final is negative 3,2 times 10 to the power of negative 9 coulombs. And this one, okay, for cloths, what is charge for this? They didn't give you, but what we know, final charge for this one, positive. Oops. Yeah, positive because electrons moving this way. So positive 3,2 times 10 to the power of negative 9 coulombs. I hope it's clear. Initial charge, final charge, initial charge, final charge. So now we can calculate. So what was our formula? Q equals N times QE. So number of electrons transfer equals delta Q, change in charge, over QE. And then Q final minus Q initial over QE. We are looking for number of electrons transfer. If you are talking about electron transfer, you must use delta Q. All right. So negative 3.2 times 10 to the power of minus, what was it? Minus 9. Q final minus 0 because Q initial is 0. How we know that? Neutral. They said neutral. And negative 1.6 times 10 to the power of negative 19. This is constant numbers. We are getting from constant number. And then what are we getting now? 2,0 we can write, just 2 also we can write, is fine. 2,0 times 10 to the power of 10 electrons. Yes. Number of electrons we done. So let's check our options. Gaining 2 times 10 to the power of 10 electrons. Yes, this is our answer because gaining means getting electrons. What we said, neutral object. Getting electrons, gaining electrons, getting negatively charged. Because of that, answer is A. Option B, losing electrons, no. If it is losing electrons, it's gonna get positive 3,2. If you are talking about cloths, yes, but for plastic rods, no. And losing protons, no, never, never. Protons never move, they are lazy, remember that. And then gaining 5, or that number is wrong. Yeah, gaining electrons, right, but number is wrong. All right, so question 13, also done. Let's continue with next question, number 14 now. So for number 14, please stop video and try first. All right, please try first. 5 seconds, I'm waiting for you to stop video and try. All right, I hope you have done. So you have answer. So let's see, your answer is right or wrong. So you have two charge objects, object A and B, plus 2x minus 2x. So now, what they said, let's see, two insulated, yes. Spheres held small distance, all right. So we have this, all right. Thus, they released. So if they release, what's going to happen? Because of different charges, what we know, unlike charges attract each other. Unlike charges attract each other, so they're going to attract each other. They will move to each other. They like each other, so they're coming to each other, number one. And then what we know, when they touch each other, they are getting same charge and separate, and then they repel each other. They are running away from each other. So this process must happen. Let's check our options. Spheres will move to each other, yes. And then no, they're not seeing each other, no, just they're not staying together anymore. When they have same charge, they're going to remove from each other. They're going to run away from each other. Spheres will repel each other. No, initially they don't repel. Initially, they attract each other. They are coming to each other. This option is wrong. Spheres will move to each other, touch each other, and neutral. They are changed to no. If now they don't, if your charge be, let's say, plus 2x coulombs, if you have this charge, sorry, minus 2x coulombs, they're going to make neutral because plus 2x minus 2x making 0 over 2, getting 0 coulombs. They are neutral. Yes, that is right. But for now, they are not getting neutral. They are getting just same charge. So they are going to touch each other and move from each other. Answer is D for this question. If they ask you for this question, what is final charge? What is final charge? If you want, we can calculate. Q1 plus Q2 over 2. Q1 is plus 2x minus x, or plus minus x, you can write. It's same stuff. And 2x minus x getting x over 2. Final charge for each x over 2, you can write 0.5x coulombs, of course. 0.5x coulombs. Okay, final charge. They are having same charge and they repel each other. All right, question 14, answer is D. Let's continue with next one. Another easy question for you. I hope it's easy for you. So now you have two objects. You can read all question and you can try. But let me explain. You have two spheres X and Y. They touch each other and separate. They're asking you what is new charge. All right, please stop video and try. What is new charge on each object? All right, I hope you have done. I hope you have answered. So we can answer together now. So what we have? Q final equals Q1 plus Q2 over 2. Q1 is 3 and Q2 is negative 5. So when you calculate this, you're getting negative 2 over 2, negative 1 microcoulombs. Answer is D. That's it. So we have done question 15. I hope you're okay. Just let's go back. Maybe you can write it down answer. So I hope your answer is right. So we have done this question 15. Let's continue with next question. Oh, done. Okay, I was thinking we have more than 15, 20, 30 questions, but only 15 questions for today. I hope you are okay with electrostatics. So if you have any question, if you don't get it on comment, you can just type and then I will check. I can answer your questions. If you have any difficulties, please let me know. And then I will try to help. If you want another video, another topic, if you need for physics, so please let me know. So today we have done. Thank you very much. See you next lesson. Just as a reminder, we are putting here. All right. So we have done for today. Thank you very much. See you next lesson, guys.